aspects of our research. Oh, I guess I'll say that again. All right, so we're going to be talking about computer-aided governance, which is an area of research at BlockScience that actually marries both the technical and social aspects of our research. So on the technical side, we are very committed to data-driven decision-making, understanding representations of systems and how collection of data and the funneling of that data through those representations of systems can both inform and even sometimes bias or anti-inform decision-making and decision makers of various types. And so the tricky part here is that there's some inherently subjective elements to the technical work with data, both database structures, as well as the processes that convert that data into say knowledge, which gets used to make decisions or to evaluate, measure the outcomes of decisions. But there's also some inherently technical stuff hidden in the sort of informed decision-making of stakeholders, where you can't always just run with your gut feeling, because sometimes your gut feeling is actually the opposite of what's going to happen. You think if you do this that you'll get what you want, but actually it's the opposite. So there's a blending or bleeding of the technical and social aspects of governance, especially when we're talking about governance of these these large infrastructures that support social and economic activities. So with that in mind, I'm going to go forward. Maybe there we go. So today's talk is going to hit three main sections. CAG Map is computer-aided governance map. And this is a summary of the more social science research part, where we'll look at the life cycle of decision-making processes. This isn't specifically about governing FIlecoin. It's about governing collective infrastructures, and just it's a broader class, and the research has been both informed by our experiences in the FIlecoin ecosystem, but also in many others, some Web3 and some not. And then we're going to transition into talking about the concrete technical work that our team is doing to build a digital twin, in particular an operational digital twin. It may not be widely known, but as part of the collaboration with the Protocol Labs crypto economics team, we actually built a design digital twin prior to the deployment of the economic incentives, and we used it for testing a wide range of assumptions about how the system would act with respect to the economic incentives. And then since going live, a lot of that tooling is being re-engineered to read from data until like back test and learn, and then extrapolate potential consequences, with the important caveat here that there's a lot of infrastructure building before the use. So it's building a lab bench and connecting it up to all the data feeds is different from constructing experiments and then analyzing those experiments results. Nonetheless, we've done a lot of work with the crypto economics team at PL to try to manifest real tools that can inform governance. That said, we see a big gap between the potential consumption of that as a individual group versus the consumption of that broadly. And so one question that ties us back into CAG Map is how and when do the assumptions underpinning those models get questioned and get reused by others? And how then do we basically scale the power of a code-based tool for, monitoring or assessing or even proposing and evaluating, make its way into the hands of a broader stakeholder group to help people become informed in a sort of, well, I want to assume this, or I want to test that kind of way, kind of make those things shareable and engage in a technical discourse as opposed to a purely speculative, well, I think this is better because I think if we do this, then that will happen. Now we're saying, look, if we assume this, this, and this, then given our best understanding, we would expect that, that, and that. Doesn't make it right. It still makes it a model, but you can see how there's an interplay between an informed participatory governance process and some level of visibility into both the current state of the system and the potential consequences of a change, or the potential consequences of maybe not doing anything. Maybe there's a shock, and instead of trying to rapidly adapt to it, you say, you know what, maybe it's not so bad. It looks like the system's capable of absorbing that, and maybe it's better not to thrash it. So you kind of get the idea. We've got the social process, this technical process, and we try to marry them together. So I'm going to kind of yield the floor to I guess I skipped a slide. So maybe I'll quickly hit this. We want to talk about some concepts in both the social and the technical layer. In the social level, we need clear alignment around vision and values, alignment on goals and objectives, and then we can kind of move into actually participating in a process. But obviously that process needs to be clear, needs to be aligned with the vision and values and the goals. And there's a lot of meat to, as I'm sure you know, Caitlin, to kind of taking the fit process from something more technical, transactional as it exists today, towards something that it feels more participatory because it's actually just clear how to engage for a larger group of stakeholders. On the technical side, of course, data collection, cleaning, storage, and retrieval underpins these systems. The digital twins are a way of seeing the forest and not just seeing the trees, and then using them as tools to actually participate in. It looks like some of this got cut off, but those are what if questions for extrapolation and analysis to inform decision making. And with that, I will give the floor to Burrata.
All right. So governance in complex systems, things like FIlecoin, is both social and technical. There's the actual infrastructure of the system, and then there's people engaging in that system to say, well, what do we want it to do, and how do we improve it to better do the things we want, right? So it's a combination of the two. CAG Map here will explore generally kind of what that process looks like, more around the social level. And then we'll go into how the digital twin can support that process. And this is really important, right? Because with complex systems, they're complex. There's a lot going on. And so for these things, computers can help us manage that complexity. They can help us understand what's going on. They can help us automate different types of queries to return metrics that can give us information to better engage in this process, right? So it's a blend of the two. And so this process will kind of go through kind of what that looks like. And at each step of the way, we'll kind of explore, how the technology can support the people and vice versa. An important point about this map is you'll notice there's no start and there's no end. One does not solve governance. It's an infinite problem because as long as people are involved, people will always have differing views and there'll always be new things, and it's an ongoing thing, right? And the reason for this is that if we think of quote unquote governance or any system as a game, right? There's the rules of the game, and then there's who decides the rules of the game. So in life, right, in like the physical domain, the laws of physics are the rules of the game. We don't control those. All we can do is act within them to play the game of life or whatnot. But in a social system, we create the system, we control the system. So we are in control of both the rules of the game and playing the game. So in any social system, any complex system created by people, for people, there is going to be this recursive process of governance because we have to decide what are the rules, how do we engage with the rules, how do we change the rules. Some systems move very, 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 very slowly. Some do this very, very, very quickly, right? But in any type of social system, at the end of the day, the rules are constructed by people. And so people need to figure out how to manage that, even if the decision is we don't change the rules, because that itself is a decision. And it's not bound by the laws of nature. We can always reverse that decision if there's enough support for it, right? So it's very important to understand any social system, there is governance. It's an infinitely recursive process. And the CAG map here, computer-aided governance, map and process, explores one way we might think about that. Okay, so next slide. Right, so there are dependencies. This does not come for free. So in any system, for this to work, the baseline prerequisites of dependencies are that people can participate, people can be informed, and then people can communicate amongst each other about that information to participate collectively, right? So this is really important, right? If we're looking at this in the context like control theory, this would be like controllability, what in the system can be controlled, observability, what can we understand about the system, and then coordination, how do we, what do we do with that to then actually change the system, right? So people have to be able to meaningfully participate. You have to understand what you're doing, right? And then you have to be able to, share ideas, communicate amongst each other. One way you might think about this is like, imagine it's like a car, right? And if the steering wheel doesn't do anything, there's really no point. You can't drive the car. You don't know where you're going. But if there's no windshield, if there's no odometer, if there's nothing like that, you don't really know where you're going or what you're doing either, right? So you need both. You need to know what's going on and have the ability to control it. And let's say you have a passenger in your car. Well, you guys need to, like, both agree on where you're going, right? It's kind of important. So these are prerequisites for any type of governance, especially computer-aided governance, because when you add computers and complexity, things get more complicated. Hopefully the computers help manage that complexity, but if you don't have these prerequisites, it's likely to actually get more complex. So this is the very baseline foundation. Then if we have that, then we can start to move into the CAG Map process. So next slide. Okay, great. Right. Yeah, so then we can start to move into the CAG Map process. And so essentially, we can start to look at the system, understand what's going on. We can ask questions about the system, like, okay, well, why does this do this? Why does that do that? Is this what we wanted to do? Is it not, etc. Right? You start to, like, engage with it, get curious, ask questions, etc. Right? You start to map it out, so you really can kind of understand what's going on. And maybe that actually looks like saying, okay, well, what if this changed? What if we change this parameter, right? What would that look like? And then you can start to map out the dynamics around that, maybe even build a model, right? That can help you understand, like, okay, well, if this does this, then that, right? You can share it, you can talk about it, maybe make a decision, and then see what happens, right? So that's kind of like this general process, and then we'll dive into each of these steps. So the first step is observing. Next slide. Right. Okay, so before you want to control anything, you generally want to understand how it works. In general, this is just a generally good thing, but from a purely selfish standpoint, if you want a thing to do a thing, when you take an action or make a decision, how do you know that what you do will result in the end result you want? Even if you're just thinking about yourself purely selfishly, to get the result you want, you kind of have to understand cause and effect, so you can do the things that lead to what you want, which first requires understanding the system, right? And then, in a broader context, if we want to, steer the system together, we have to understand, what we're all thinking and what we're all doing. But just from a purely selfish standpoint, cause and effect means we have to understand the dynamics of the system, how one thing leads to another, and therefore we can better understand, well, what needs to change for me to get the things I want, or what needs to change for the system to achieve its goals, in a broader sense, right? So that's the first step.
Can I make a comment too? You'll notice that there's some things on this slide that are in the other sections. That's because they're not independent of each other. You're entering the system not at the beginning, but always in the middle. So there exists documentation, there exists things you can interact with, there exist existing maps or models made by others. And so this isn't totally independent. It's actually you're observing using the affordances for observation that have been previously made available to you. So we're not at the beginning in a sense that there's no dependency on other things.
Yeah, and so as you go through this process, more and more things, maps, models, data, metrics, and things will be created that then help inform future observations or observations for new participants and whatnot. And also another thing with the observe real quick is that what we're observing here is both social and technical, right? So we're observing, A, how do the mechanisms work? But B, how do people expect them to work? And what is the precedent for people engaging with the system to then shape it to do the things they want, right? So you have to understand both. It's both understanding the people, their goals, their interests, the expectations of the system, as well as technically how does it work? So then when you submit a FIP improvement proposal, you can say, well, the system works like this. We would like it to work like this. Here's what might help change it to be more like what we want, right? And that starts with observing both the people and the mechanisms. So once we do that, right, we start to ask questions like, okay, well, what would it look like if to move it into something we'd like? And these questions are open-ended, and generally the more you observe, the more you can answer your own questions, which is great. However, if you observe the system quite a bit and you have a question that you just can't answer, and you ask people about it, you talk to people about it, you think it through, you're like, okay, well, what do other people think? What might feed into this, et cetera, et cetera. You do everything you can, you just really can't figure it out. It just doesn't seem to make sense. Well, then you might have something that's actually worth inquiring into more, right? And so then you might say, okay, well, So, what if blank, right? What if we change this thing? Or what if, we added, we wanted to kind of steer it in a slightly different direction, or, whatever it is you want. Then you're like, okay, well, let me map this out. Like, what does this look like, right? So you might make a diagram. You might say, okay, well, here's these different dynamics. It might say like, okay, well, these things feed into these things, like a causal loop type situation. It might be stock flow diagram, whatever. You can use any bunch of tools, but then you just kind of like map it out. Generally, in doing this, you might answer your own question, but you might not. Yeah, what's up?
So mapping tends to be structural unless, like we're going to get into modeling, but I think there's often maybe a difficulty in differentiating mapping and modeling. But in order to clarify that, one of the things I like to point out is that if you haven't mapped, then you don't kind of have enough of a lay of the land to scope a model. So mapping as an exercise allows you to actually refine your questions and help understand like what is the scope of analysis to help answer your question, because we don't necessarily want, sort of unbounded complexity in our representations, in our models. So mapping type representations tend to be maybe more breadth first in an understanding of how parts relate to each other, both social and technical. But that's why you see a lot of diagramming software here and diagramming methods, as opposed to, we'll get to modeling. But I like to make that clarification because I'm frequently asked about like why these are really different, since they're both representations.
Yeah, and more importantly, right, like the map provides perspective. So the map is not the territory, right? The map is not the system. You're saying, here's my perspective of these general dynamics that I think are important. And then you can say, okay, well, then let's get specific about like, in the model, okay, this model is this particular slice of the system with this viewpoint, right? So the map can really help put things in perspective and understand the dynamics around a thing. So then when you go to present a model or whatnot, you're saying, okay, this is the specific thing I'm working on. This is really important because that way people can look at your map or your model and they can either question your results, or they can question your assumptions and be like, okay, well, you looked at it in this way, in this context, but did you think about this other dynamic that would affect that context that could then change some of the underlying assumptions, right? And if you make this explicit, it's a lot easier to have informed participatory discussion about it. If you don't, then it's a lot harder. So it's really important for this.
Yeah.
Again, if your original goal is to actually have the intended effect that you want to be aware of all the different dynamics that could affect that, so that you can then actually achieve the thing you want. And the more people understand that, the more you can get different perspectives on that.
Yeah.
So it's slightly different than.
Go ahead. I wanted to throw in a point.
Well,
I'll let you finish your thing.
Oh, I was just gonna say, so it's slightly different than a more traditional political process where you just say, I want this, and then you just advocate for it, right? Here we're saying, I want a result because, and let's explore how we can best arrive to that, right? And so it's really important that you understand the dynamics around this, because in a complex system, it's very easy to think you're going to achieve a thing, but actually there's an unintended result that's something completely different, right? And so in this system, it's really important to be very specific about what you want, what problem you're trying to solve, and the assumptions that go into that then support what your idea is of what those dynamics are.
Yeah, I think the thing that we're doing here is we're sort of injecting some more sort of, let's call it epistemological thinking to the political process, because once we introduce representations, these potentially performative representations of these systems, then we're pushing some of the some of the subjectivities down the supply chain. The modeling assumptions actually, or the data choice that you choose to use, or what questions even you're asking, actually start having a direct effect on what conclusions you might reach. So if you want to have a healthy informed process, you say, look, modeling is great, but the process of modeling is subjective and the results will depend on the assumptions that you take. And so we try to bring those into the forefront and impose a more, let's say, more scientific approach that says, if I assume these things, if what I'm trying to accomplish is these things, then, we would expect to want to do this. But if you think that our goal should be something else, then of course you're going to want to do a different thing. If you make a different assumption about the future, then you might come to a different conclusion about what actions we should take. And we want that to be accessible. Someone could look at, say, two models and say, well, under these assumptions with these goals, I would conclude we should do A, but if I change the assumptions or the goals, then I could conclude B, and that can maybe help unlock a more productive discussion rather than just like A is good, B is good, blah, 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 and sort of unpack that and even discover meaningful compromises, which we'll get into discussions and whatnot after, that like are actually empowered by the modeling rather than just using the modeling as enhancing the talking past each other. Like I'm objectively right versus you're objectively right, and arguing when in reality, a lot of the hidden assumptions are actually driving the differences in opinion. We want to tease those out and make it so that the data science or this actual empirical work is facilitating the participatory process rather than just used as whoever has the biggest guns in a data science sense comes in and says, I proved that I'm right the best, which is not actually a very healthy approach. Okay, I'm done rambling, but yeah. I hope that helps.
Right, so TLDR, a model is not an oracle. Again, a model is not an oracle. It is a thought experiment with code written by a person just like you and me. It is not a magical oracle that provides the answer. It is a thought experiment, and it can inform discussion. So we have to present, right? So essentially, if we're going to have a discussion about this, if we're going to say, well, here's what I think, you have to share that, right? If it just stays on your local machine or whatever, it's not doing anyone any good, right? And in a complex system that has multiple stakeholders, for decisions to get made, if all those stakeholders do have agency to participate in the process, they all kind of need to participate and agree, right? So you kind of have to be like, okay, guys, well, hey, we want this thing. Here's why I think it's important. Check it out. So this part's really important, right? It's where you get feedback. It's where people can help you understand maybe if you missed something, right? So maybe someone shares your goals, but they're like, well, I agree that this is the thing we should do, but you've made this assumption. I'm not sure if that's correct, right? And then you can like, tease that out and better understand what's going on. Also, people might disagree with the original thing you're trying to do, but they also might agree with the way you went about constructing the model and say, okay, well, this model looks good, but I don't really think we should go that way. I think we might want to do this thing. And then people can actually talk about that in a more informed way because you've shown your work, right? It's like open source with all the bugs are shallow if you actually show how it works, right? Same here. You show your thinking, you show how it works. And that way people can question the model, they can question the assumptions, you can have a discussion. And that's really important, right? Because then the quote unquote legitimacy of any decision is based on, well, did it technically go through whatever the governance process is? But do people actually agree on that? Or do people actually agree on the way that happened, right? So back to our earlier point that systems are both social and technical, if people understand a decision, they understand a proposal, they understand how it works and why, then there can be some sort of agreement on the legitimacy of that on a social level, in addition to the, it be going through the official governance process, right? And the more you show your work, the more people can actually understand what you're thinking and why, and you can have an intersubjective agreement or disagreement, but you have something much more interesting to work with. So then once we've presented, we go into the debate, right? So the debate, like I said, people disagree, right? If we all agreed, we wouldn't need any of this. We would just all be good, right? And that'd be great. The other thing is, like we said, people have disagreements about what they think the goals are and or how they think we should arrive at goals, right? And so that's okay. And so the more we can be like explicit about what we're thinking and why, and the more we can help people understand that and participate in it, the more it's likely that then people can arrive at some sort of intersubjective, understanding of truth. And then you can be clear on what you agree on and what you disagree on. This is really important because if the issue just kind of devolves into, well, it's my idea and your idea, and then they clash, it's not very interesting, right? It's just whoever has the most social capital wins. But if you can actually be clear about what you agree on and what you don't agree on, then you can say, okay, well, we're aligned in these ways and this type of vision and these type of values and these types of goals, but we disagree on this particular point. And then you can really scope the discussion around identifying and solving that particular point versus just arguing. I see a hand.
Functional or productive. Oh, sorry. it wasn't me. Well, let me make this point and I'll concede the floor.
Okay.
The debate needs to be productive and functional. So we've made a big observation in a lot of organizations that there's like debate that is sort of just thrashy versus if they're sufficiently well informed and the norms are in place for good faith discussion, you can actually discover new solutions that are actually better for everyone rather than resulting in situations where you just devolve to, as Burrata said, whoever has the most social capital wins and half the community is upset. Actually enabling a informed governance process means also discovering new alternatives through the debate process in order to actually converge on something that is, more acceptable to a larger number of stakeholders rather than just being stuck with the initial, ideas that are thrown out there or presented. And then the question.
Yes, just a small point. I was wondering what you mean by sacred versus profane. Does it have to do with like norms alignment?
Yeah, so the sacred versus profane concept addresses the difference between the things that are viewed as untouchable and the things that are like day-to-day or mundane, in the sense that it can be easy to deify certain patterns as like, well, this is just the way that we do them. And so it's got two dimensions to it. One is the extent to which we hold certain things constant processes, think of them as like constitutional things. They're there and we just take them as they are and act within them. But then there's a secondary notion that we don't actually want things to be, so sacred as to be unchangeable. We just might need to be clear that if something really isn't aligned with our mission, vision, values, etc., we may actually need some processes to unlock those things. And so we use the terminology to call out let's just say the recognition between the things that are, mundane day-to-day happening within the system from the things that are effectively held sacred and untouchable, but then actually revisiting that itself when necessary, because you don't want to hold something sacred if it's fallen out of alignment with the real needs of the system.
Got it. Cool. Thank you. I'd never heard that term before. So.
Yeah, and also, so another way to think of this is in the context of critical thinking, right? Critical thinking is important for, good decision making and understanding stuff and whatnot, but critical thinking requires being critical. You have to critique things, and nothing should be so sacred that you cannot critique it. Because once you stop critiquing something, you stop understanding it, it stops being functional, it kind of just degenerates into this kind of like, ossified layer that usually over time does not serve the needs of a system. So it's very important that you can critique every part of the system, but with the caveat that you want to be critiquing the ideas, not necessarily people, right? So you want to be hard on the ideas, question everything, but also understand that, that what you're trying to do is understand and, critique and improve the system itself. You're not trying to directly attack or critique people, right? Which would be one differentiation between a healthy political debate and an unhealthy political debate, right? So yeah, important distinction there.
There's also another point you make frequently, Burrata, about how fast the certain things can change. So just because everything is subject to criticism and evaluation doesn't mean that it should be on the same time scale, because some rules about how you change the rules need to be harder to change and require a larger sort of action in order to make an adjustment. It doesn't mean you shouldn't critique the rules about making the rules, but you also shouldn't be thrashing them. The rules need to be, the day-to-day activities are faster, rules then are sort of slower, and then rules about rules are slower. And there's a sort of natural sort of frequency domain concept that you look at how difficult and how frequently and how big the changes are on a system affects sort of how much critical mass is required before it's worth actually making a change at all. And we need to be careful not to create a thrashing. So there's this really tough challenge around holding everything up to a standard of review and criticism without also going way in the other direction and then thrashing the system around because it has no momentum or no conservative forces.
Right. So on the next slide, we'll have where we actually make a decision, where we decide. And you'll notice there's kind of just a box. It should be a black box. It's a blue box, but whatever, for the governance process. Because again, like this is a general high level view of governance. we're not assuming what this specific system looks like. We're not assuming how fast your governance process should go, what is being governed, etc. That is all contextual to a system. So yeah, like Zargham says, some things are meant to change more slowly, some things can change more quickly. We're not making assumptions of what that looks like in any specific system here. We're just saying there is a governance process to govern the thing, and we hope that it is appropriate for the thing being governed. That happens there. And as long as people can participate and they view the process of participation as legitimate, there can be some political debate, but a decision gets made. And this is kind of for that. Although what that looks like is very, very contextual and specific to the system.
Yeah, but I also would argue that we're not saying it's not important. We're just simply throwing a blanket over it because this particular research is drawn from a wide range of processes. And I think that slot is very much the slot we discussed with you earlier, Caitlin, about the sort of the evolution of the FIT process. And so something goes here. It's just a question of, that needs of that process bubbling up from the specific thing being governed and the stakeholders within the thing being governed. And sort of, we didn't want to be overly impositional about that decision-making process, not just the process of voting, but the sequence of processes that make up, basically deciding to do something. I don't know if I miss anything, Burrata. Do you want to go to the next slide?
Basically that. And the idea by keeping it abstract here is this could apply to changing the FIT process itself. This could apply to acting within the FIT process. That could apply to a subsystem, right? But by keeping it generic here, it's just the general kind of process. But then what that looks like for any specific system is specific, right? So, but the idea here is that a decision gets made. And how those decisions are made varies, but it's important that decisions do get made at some point. Yep.
Yeah, and I just want to note, I guess for everyone, but also specifically for Shannon, that when we think about the different contours that individual governance processes could have within this framework, yes, it could be the FIPS process, it could be whatever scope of protocol governance we're discussing, but within specific stakeholder communities within the FileCoin ecosystem, that FIPS or governance thing can also be encapsulated within different decision-making processes that other stakeholder groups also implement. So when we think about the way that different implementation teams decide to make changes, or the way FileCoin Plus decides to make changes, they may still need a FIP and they may need to go through our processes as well, but their own deliberation happens in separate spheres. And that's one of the challenges we have in connecting different people and ideas over time.
So you're necessarily needing mapping to understand the graph of power relations between the subgroups, because effectively decisions by one stakeholder group may still have ramifications on others, and they may have bindings through governance that determines, okay, hey, we want to do this thing, but we may have to go through another process to get it proved because it's going to have effects on people outside of our immediate stakeholder group.
All right. So we go through that whole process. We understand the system. We ask questions. We present some ideas. We debate them. And we make a decision. Great. That's not the end of it. So as we mentioned before, it's an infinite recursive process, right? So yeah, if we just make a decision, that's okay. But just saying something is something. Doesn't actually change anything, right? It's important, but what really changes things are actions and execution. And like we said before, in complex systems, often outcomes and intentions can diverge, right? So you can think you're doing a thing that will have a certain outcome, but maybe the outcome's a little different, right? And so it's really important that we monitor to see, okay, we had this hypothesis, we had this intention, we wanted to make this change, and we did X. And that could be we made a decision, or that could be we decided not to do something. Either way, we should have a hypothesis of what is the likely outcome of either thing. So if we choose to make a decision, we say, well, we chose to make a decision because we expect this to happen, or we chose not to make a decision because we think that this will happen. We can then monitor to see, did the thing we expect to have happen actually happen? Very important. Learning happens when we connect reality to thinking. If we don't do that step where we connect the reality to the thinking, we don't learn, we don't know, we just kind of made a decision, then we just kind of stumble on in the dark, right? So it's very important that we monitor to see if our intended outcomes actually happened And then if they did, then we could say, okay, great. So we achieved the thing we want. Let's monitor it to make sure it consistently keeps doing the thing we want as long as we keep wanting it to do that thing. Or if, let's say we chose not to make a decision, and let's say you submitted a proposal and you're like, I think we should do X because of Y. And then the community is like, no, we don't really think X is going to lead to Y. So actually, we're not going to do that. Well, if you monitor and see what happens, then you can say, okay, well, if you had a hypothesis, like if we do it, this will happen. If we don't do it, this will happen. Then if the outcome is, okay, well, like I told you guys, if we don't do it, this thing will happen. And then you can actually monitor it and say, look, the thing happens that I told you we should care about that you guys didn't care about. Then you can maybe revisit the proposal and say, oh, okay, this actually is a problem. We should actually maybe do something about this. That's only possible if you actually bother to see what happened, right? You have to monitor it. It's very important.
But also not just monitor it at the micro level, like understanding this whole forest for the trees concept. It's very possible that you do a thing, and if it's code especially, or a process that you can, the first order impact of what you did is going to happen because you just did it and it's there. Like I changed the code, it does this now, or I changed a process and we followed it now. But whether or not that change had the intended systematic or ecosystematic effect is something that might take longer to play out, but it's also something that you can't see just by observing whether you did the thing. It'd be like me taking a spring and I have the hypothesis that I push the spring and it's going to move and stay in the direction I moved it in. But if I don't wait to see that it sprung back, if all I'm measuring is my actuation, my input, I exerted a forward force. Great, I monitored, I exerted the forward force. Yay, I exerted the force. If I'm not actually observing that system and realizing that the system's dynamics led to it bouncing back at me, I may never see that. And especially in cyberspace instead of physical space, it's actually exceedingly common for people to only pay attention to their actuation. I did this, ta-da, and not I did this and the system responded in this way over the next hours, days, weeks, months. And so if we are not putting in an apparatus to understand or see the system, again, mapping, models, etc., then we can't actually monitor properly because we're only really monitoring, hey, I did what I said I did, not the thing I did had the intended outcome, or the thing we did had the outcome we intended. And that leap from individual direct action to systematic consequence is a critical leap in order to actually move from small scale things to big institutions, big networks. And so, bringing that from the sort of, let's say, this richer institutional or even cyber physical systems theory to this context is saying, look, we're not done just because we showed we did what we said we did. We need to be monitoring at the level of it had the intended consequence, or it had at least an acceptable consequence.
Caitlin, you still got your hand up. I don't know if do you have a question or is that from before?
No, sorry, it's from before.
Oh, okay, cool. Okay, yeah. And with the monitoring too, right? If we did all of the mapping and the modeling before, that can help us also better understand the dynamics with respect to the monitoring, right? Because in a complex system, often there's lots of different things that can affect an outcome, right? So then if in the monitoring, maybe like, we didn't quite have the outcome we wanted, and that can inform, well, did we make the right decision, or was it that there was an assumption baked into our model in the first place that was incorrect as well? And if we have all of that information, then we can actually go through that process to better understand the dynamics of our system. And so the process is really recursive, right? And the more you go through it, and the more you have better tools, techniques, and information, the more it can help the process itself. So yeah, next slide. Right. So the process itself, right? Like we'll observe the things we monitor. We might ask some more questions. We might revisit the maps. Maybe build some new models, etc. It kind of just goes on and on. And it doesn't necessarily have to go in a perfect circle. You might observe, ask, map, model, go back to monitor, observe, monitor, observe, monitor, observe, ask a question, observe. You can kind of jump around here. The idea is like it's an infinite process of people trying to go through some sort of process to control resources of a system, allocate resources, etc., to achieve the goals they want. And this is like kind of this ongoing loop.
in my experience, there's little micro loops. One of the reasons I like the segmentation that Burrata came up with is because you see monitor, observe, ask loops, you see ask, map, model loops, you see model, present, debate loops, and you see debate, enact, monitor loops. Those are really natural subloops that emerge. And to his point, there's any arbitrary subloops over this circle, but this ordering kind of makes sense because even the 3-length subloops actually make a lot of sense and you see them in practice.
Yeah, so so this process is inherently complex, right? And it deals with complex systems, and there's people and technology and all sorts of things. And in these systems, right, the more people are aligned about shared goals, intentions, outcomes, etc., the more they can collaborate through this process. If they have divergent views, then that can be explored through the process as well, right? But the idea is that this can help people engage in governance in a data-driven way, to go through this process to hopefully clarify assumptions, get clear about what they agree on, what they don't agree on, and then advocate for their interests to make changes in some general way. And so it's complicated, right? Obviously, there's a lot going on here. So one of the things we want to do is help provide, computational tools and techniques that can help support this process. So that's really kind of one of the things with the digital twin, right? Is we really want to help make this easier. So everyone doesn't have to be an expert in, building systems models or anything else, right? We want to help make the tools more available so that people can use them to, upgrade their understanding of the system, or have automated monitoring that gives people feedback on the things they care about or whatnot. So we want to try to help support this process. So yeah, so Zargham can talk a little bit more about what that looks like.
I'll give a, oh, go ahead.
Yeah.
Yeah, so
so we're building computational tools and techniques to support this, and you'll talk about that.
So I guess I'll jump off this slide and point out that where this was all a big explanation of why we see this as important for participatory informed governance of large ecosystems with technical and social dynamics. And what we're really digging into on the what is our digital twins work, which we have deployed a small army of data engineers, data scientists, and economists to really try to create some models that are suitable for monitoring. And while this work is sort of under development, we're going to give you a bit of a progress update, but I want to pose this as sort of a why, what, how, where we're saying why is CAG Map. This is how we understand why it is so important to build these things, to open source these things, to create education around digital twins, the kinds of stuff we've been doing with the Token Engineering Academy, to increase the, let's say, new stakeholder group of people who can, build these things and teach other people how to use these things. But ultimately, we're talking about the monitor and model slice in support of observe and ask and present, debate, and enact, right? Our technical work is kind of in this diagonal monitor model axis. And this has looked like an ongoing relationship between the BlockScience team and largely the Protocol Labs economics team, which is maybe one of the reasons we were so enthusiastic to hop on this call, is because we understand that we're actually a stakeholder in the FileCoin ecosystem. And we want to make sure that, while we are working with the experts at Protocol Labs, that we aren't just bottlenecking ourselves either, that we're meaning to provide, intelligence infrastructure in the form of, models and monitoring software that empowers the whole community to have some shared reality to work within, but without also imposing that reality on them. So retain some of this forkability, some of this revising of the assumptions, or like using the tools to come up with proposals for different goals, etc. But it's a tricky challenge to balance this, because at the end of the day, it does require expertise. And the question is whether, as public servants, you can use that expertise to create sort of infrastructure for governing infrastructure. Because at the end of the day, the economists, data data engineers, and sort of some of the cloud computing stuff we're looking at for making this a usable tool by other people is a lot of work, and it results in equipment through which others can become more informed and participate. And we are also, of course, doing some informing. We're answering questions and using the tools as we build them. nice to dog food, but also kind of challenging when our primary mode of interaction with the Filecoin ecosystem is one team, and we are trying to understand how, as governance matures, the outputs of this, research infrastructure, this, modeling and monitoring becomes part of the public good of the Filecoin ecosystem more readily. And so with that, I'm actually going to give the floor back to Sean, who's going to give us an update on the actual progress on the digital twins specifically. So we could think of this as the how. The why is CAG Map, the what is digital twins, which are sort of performative models to be used for monitoring and to be used for things like what if analysis and whatnot, and the current state of that work, how we got here, where we are, where it's going, and then we'll come around to questions.
Thanks. So I'm going to first kind of introduce, just in a general sense, digital twins and any sort of kind of background knowledge you might want to understand about it. And then we can go into kind of Filecoin specific pieces of this. But yeah, let's go to the next slide. Digital twins are kind of meant to replicate a subset of your system behavior. You don't have to redesign your entire system to do simulations and stuff. What you're really trying to do is zoom in on what you are trying to study and build this kind of digital twin representation to allow you to study it. The framework is based upon real data. So you're trying to use as much of the actual data you're getting from the system to kind of feed back into this digital twin. And there's two different kinds of types of digital twins, which are your design digital twin, which is more based on trying to design policies, do research, understand things. And then your operational digital twin, which is much more centered on how do you monitor a system, how do you do kind of short-term projections into the future. And so it's kind of those two different categories. A lot of times the overlap is, pretty huge, but those are kind of the two different ways to think about it. And I think the way to really be thinking about these things is there's a feedback loop of saying, are there any kind of alternative parameter ranges, models, or systems that are more appropriate to what we actually observe in the live system data? And so we go to the next slide. So why actually use a digital twin framework, right? And there's a couple different reasons why. First of all, system monitoring. And the importance here is when you've built out a digital twin framework, it will allow you to backtest essentially what is actually happening versus what should be hypothetically happening based off of maybe some of the policies you have discussed and looked at. And if certain numbers are off, it may illuminate that the policies that you designed aren't actually behaving as you kind of wanted. So I think that's number one of the most important kind of things that it can achieve. It's also useful for policy design. So saying once you have a system running and there are community members who are trying to ask, what if we change to this policy? You can kind of do A/B testing in this way by having your digital twin running with one set of policies and another set of policies, and then actually comparing what the impacts on the system are. And in the long term, we're hoping, have this digital twin be open source that anyone can run it, right? Right now, I don't think we necessarily have it open source. I think it is private, but in the long term, that's the plan, to have it that anybody could even run their own digital twin simulations.
They also need to be instanced effectively. They are computationally intensive. So there's a difference between hosting a version of it with a range of configurations that are encoded so that people can explicitly change the explicit assumptions versus forking it and instantiating it themselves and changing the deeper assumptions. So just keeping in mind, it is a representation. So you can build a version of it that's deployed in a cloud-based infrastructure that other people can use. But of course, you have to pay the cloud costs for them using it. Or you can make it possible for people to create their own instantiation. They bear the cloud costs of using it, but they can make whatever changes they want in order to explore their own questions or make their own assumptions.
Yeah, exactly. Wait, can we go back?
Yep, go ahead. Sorry.
System specification is another key component of kind of digital twin framework. A lot of times when we're trying to define, let's say, like a mathematical specification of a model, a digital twin will help you to actually go through and see how all the mechanisms work together. And it kind of forces you to see where something might break and where you need to better define things. And then the last piece is just community, which is having this kind of digital twin can be a really good resource for people in the community who want to see the actual process in action and be able to kind of see some of the code or like how mechanisms are actually coded out to reflect what they really are in the system.
I would also add, though, that with community, there's often a necessity for other layers of say, web development to make things accessible. So the digital twins themselves are pretty heavy computational science tools. They produce data sets, and they can even be scheduled so that they run and produce new data sets. But it is often practical for those data sets themselves to be stored in a backend of a website of some kind, so that if you have non-technical experts, people who are not technical experts, who are non-technical community members who aren't going to get into the data science of it, they just want to see what the current projections are or see the past trends in the system, they can still engage with the models, but they'll have to engage with them from the model being run. They produce data sets. The data sets need to be staged into databases or data warehouses that provide the back end to a front end that allows data exploration. And that's a different work. And I emphasize this because I think there's some conflation between the building of the intelligence in the behind the scenes, the dynamical systems, the machine learning to fit the processes, the back testing, the extrapolation. That's all effectively in the AI category of work. It's used in automation, control, and large scale systems to understand. And then there's a second layer of work that takes that thing as a given and makes it more accessible, creates UIs that serve different stakeholders.
There's kind of these 6 core components in terms of digital twin. This is actually with it in terms of it actually running. And so these happen sequentially, and essentially you first are running kind of a data preparation step. And so this is encapsulating all the different data that needs to be brought into the model for it to be actually running simulations. Your second step is then running a backtest model, which is just taking this data that you have and all the mechanisms in this actual simulation that's been written in CAD and running the simulation. And this will allow you to see kind of how close your model is to the actualized data over this backtest period. Then we kind of move into the extrapolation phase. And so the first part of that is that step 3, which is fitting extrapolation models. So for any sort of input into the system, you can think like in terms of FileCoin, the example would be like storage growth, right? You need to kind of have an assumption of what might happen to storage growth in the future. So you're fitting extrapolation models to try and actually figure out, based on our past results, what do we assume could be kind of a range of possibilities, what are the distributions of that? Number 4 is actually then extrapolating out all these different signals. So this is just random sampling. And then the 5th one is taking these random different paths you've sampled and running Monte Carlo simulations to try and see kind of a lot of the different paths that could be happening over the future based on the extrapolating signals. And then finally, there's the analysis and kind of visualization step. And it's a built-in, right now we have it built so that Jupyter notebooks are essentially run and then exported as HTML that then will show you different kinds of things like the comparison of the backtest values and also extrapolated paths with kind of like confidence, well, not confidence intervals, but bounds.
Clouds. They're kind of like particle clouds because these have a lot of uncertainty. What you would generally do is you're fitting these models based on these past stochastic processes, sampling from them, running them through the dynamics. And when you run stochastic processes through dynamics, you get clouds. What's interesting about clouds, though, is that if there's a real powerful effect in the system, you can still see clouds collapse, not just expand, or you can see the circumstances under which the clouds actually shrink. And small clouds means higher certainty, fat clouds means lower certainty, but it's an effective way of getting a sense of how certain the consequences of a decision might be, as opposed to just having an average or expected outcome.
Yeah, exactly. And then I just want to kind of also highlight some of the supporting components, and a lot of this is important. So when I'm talking about community, obviously, I think Michael kind of was talking a lot about how there's a need for kind of potentially web visualizations and stuff like that. But there's also community in the sense of people who want to get involved as developers or who are pretty good with coding and want to, be actually, as opposed to being purely consumer, but actually maybe participating in, maybe raising issues on GitHub or whatnot. These kinds of different things will support that. And so
Sorry.
Code documentation, I think, is one really important part. And I think the documentation right now that's been being iterated on is documentation in terms of the data, documentation in terms of like what the inputs and the parameters are, and then finally documentation on what the kind of mechanisms are, so the substeps and what the flow are. And so these kinds of things right now are being written as Jupyter notebooks so that they can have an interactive component that someone can go in and actually be using it. And it's, I think, very important if you want to be able to involve other people running in the future as an open source project to have very strong documentation. Testing is also similar in this idea of like when we need to expand to a larger amount of potential developers, it's very important to have strong unit testing, integration testing, and so on, so that when people are trying to push branches, for example, that it's not crashing the system. And so I think that's, everyone will agree that's a very important thing for the stability of kind of the system. And then also just the other kind of supporting documents are mathematical specifications and implementation guides, which are documents explaining kind of how these systems work. Mathematical specification is more specific to obviously kind of the math and how these different things in terms of numbers are interacting. Implementation guide, you can think about it more like if you were trying to help a smart contract developer, the implementation guide is much more on the, here is exactly what needs to happen. This needs to go here. This needs to go here. So those are kind of the supporting components.
Mathematical specifications are often one of the things that people maybe have the least understanding of, because they come from, in a way, the legacy world of engineering things in physical space, where you have an abstract representation of how you want something to behave, and then you have a manufactured thing, and you want to be able to validate whether the thing that you built actually matches the specifications. What is common in the case of software is we get what we would call verification, where you say, do this, and you check whether the code does that. Like, is it implemented germane? Or, have we written the code that we intended to write? But that is actually quite different from validation, which is, does the emergent thing actually have the properties that was intended? In a mathematical specification, you're working with something that's an abstract representation of your system, but you're capable of expressing the relationship between, say, the mechanism at the implementation definition level and the systematic property that it's meant to impart. My preferred example for this is the simplest one. It's actually just Bitcoin, in that the implementation of Bitcoin preserves the no double spends rule, but the property that is emergent from that is the fixed supply of 21 million. And if you look really carefully, there isn't any code that says the supply of Bitcoin expressly is 21 million. It's actually a property that comes from the mining reward schedule and the conservation from no double spends. And so the relationship between an emergent systemic property and a directly implemented protocol is actually something that needs to be represented mathematically if the complexity is growing. So the way in which a large number of potential interacting mechanisms do or do not expect to preserve a property at the system level tends to live or get evaluated analytically. And then, of course, validated through collecting data and comparing the observations of the system's dynamics to the desired properties. But you do really need mathematical specifications if you want to maintain an understanding of the relationships between sort of tactical changes to specific mechanisms and their potential impacts on aggregate sort of system level properties that affect the end users, say, trust in the system or the general trends in that ecosystem. Sorry, I have strong feelings about math specs.
No, you're good. I didn't have anything. Yeah.
Okay.
So I just wanted to give the kind of now the current overview of what the actual FIlecoin digital twin, where it's at. So currently the framework functions end to end through all 6 steps. And in terms of the back test, it's gotten closer and closer, but it's tracking very closely to these variables. The focus of this kind of digital twin is on the macroeconomics, and that's to mean that we're not trying to spend our time going into every single potential deal and tracking that, for example, because like we were saying, you don't want to, what is this saying? Lose the forest for the trees. And so that's why it's, we're looking at the macroeconomics perspective within that. That is the subset of behavior that we are trying to track. it now has modular inputs, which is great. So in terms of those modular inputs, we have things in terms of what the rate of growth and storage will be, the rate of burn, and then the slippage between hypothetical block rewards and actualized block rewards. And by that, I mean, this is actually something that I had realized after digging in a little bit, but in this system, the majority of the hypothetical block reward that's supposed to be mined happens, but there's of course times where a block doesn't get mined when it's supposed to. So there's like kind of the slippage between, right? So there's inputs to kind of allow you to toggle some of these different parameters and see what the effect on these systems might be. So for example, if growth was to all of a sudden ramp up crazy, what is the effect on the system? Is it the system stable to, you know, any sort of growth patterns or something that you might be either anticipating or you want to kind of like stress test the system with? There's also so documentation testing are both being iterated on. It's obviously a very long process. Just you know, these unit tests, I would guess that there'll be probably 100, 200, maybe even more by the end when you think about how many pieces of this that you're testing. So it just, you know, it takes a while to do a very kind of due diligence heavy
There's
job.
something inherently recursive about our discussion about CAG Map here, is that the digital twins that we're building for FileCoin are sufficiently complex that they effectively become a shared collective open source infrastructure in their own right. Some of the pain of doing that in a collective way has been manifest in our teams. We've got some other team members working on some machine learning models for fraud detection in Gitcoin that we have been collectivizing, like transferring from operation internal to us to collective ownership by a specialized group of stakeholders, a sort of sub-DAO in the Gitcoin ecosystem. And so we haven't gotten to that kind of dealing with that kind of handoff here, but just an understanding that with sufficiently sophisticated data infrastructures, they retain a sort of necessity of some centralized expertise, at least at the level of working groups and experts who really know how they work. But if you want to retain participation, you need to make them open source and make it possible for people to collaborate. But that creates a whole new point of friction around, again, testing, maintaining integrity. And so we come back to this question of how do you govern algorithms again and again and again, because even these, if they become sort of sources of truth for a participatory governance process, are again, you know, attack vectors from a political standpoint, because if the control of the information flow belongs to a politicized actor or a group of highly politicized actors, it undermines their ability to provide the public service of information. And so, you know, without going too far down that tangent, it's just really important to understand that doing this well for a system as complex as FileCoin is a technical infrastructure serving a social need again. So that's a fractal of the broader FileCoin challenge.
Yeah, definitely. And not only for, I will say testing's not only for other people, it's also for me. You know, right? It's so easy when you have this kind of large system to kind of forget that, you know, changing one mechanism can totally blow up something somewhere else if you're not careful. So, you know, it's also for me. But the last kind of two things that are kind of happening is, so I've been, you know, there's lots of data and mechanism quality projects just over the long term. I'm anticipating that we'll be able to get kind of this back test very, like, it's already very close, but like nearly, you know, touching at all points. It's already very close to that. And then also we have a standardized kind of Jupyter notebook outputs that are being ran, and that I will, in 2 slides, I'll show that. And that's just nice. The future,
You ready? Okay, cool.
The future kind of FileCoin stuff, there's a lot of different points. Not all of these are, you know, going to be happening in the very short term, but one of them that is very exciting is having an operational cloud digital twin. So as we're talking about kind of system monitoring and having even potentially interfaces of, like, if one of the things that it's used for is making kind of these short-term kinds of predictions of here's this cloud of where it could go, it'd be good to have that as something that community could view. Completion of testing and documentation will hopefully come. And I say completion, but obviously it's always that kind of circle of more and more kind of coming through. But when I say completion, I more mean that there's at least the majority of the testing and documentation is there and it's just really about cleaning up, adding new things, etc.?
A minimum viable to be put into operational use. Because right now we're still in this create phase where we're trying to create a piece of infrastructure, and in a sense it hasn't been deployed, because you would argue it's deployed when there are other stakeholders consuming it. And so we're trying to work against, like, what is the minimal set of deliverables at which point the tool that we have built is able to inform people who are not us.
So I just saw this question about the documentation being publicly available. So it is within the repository. So they're kind of living as Jupyter notebooks right now, mainly because, like I said, I like to have the interactive. So it actually has like the source code, has kind of examples of it. Those will be public once the actual project is public. But right now it's still, I think, private repo.
I'm not sure what the criteria are actually for publicizing it. We can come back around to this, but for me, this is actually kind of an open question that I think is pointed a little bit at the FIlecoin Foundation, which is like, when and where and how do we want to go about transitioning these from effectively internal operations research projects into something more than that?
Yeah, and in my view, I could see us more doing kind of two-step process of starting to allow like some small stakeholders in to start doing it, so that we don't just
blow ourselves up with a bunch of
like having a soft launch then going in, I think would be great. But the other kinds of things that will be kind of coming in the future is kind of a greater extrapolation flexibility. So right now there's a couple different parameters that can be tuned or kind of changed around to test different kind of research hypotheses. So overall, more and more avenues for the extrapolation will be added. There's a possibility of kind of doing a standalone data piece. This is just in terms of, as the data processing architecture for the digital twin gets bigger and bigger, it may actually make sense to have it be kind of separated in the sense that it can be used for other types of work, but also having it hosted in a database. So that's a potential kind of avenue that just recently we've been thinking about. Community outreach will, once it's public, will become a very big, important kind of part in making sure that people have kind of the tools to understand how to use it and how it might impact them, and getting kind of feedback. And then the last thing, it's, obviously there's the possibility of kind of future forks for when people are looking to take this and then use it for different kinds of research goals, and they want to use it kind of as a base, but do something different with it. Yes, we can do next slide. And this is just kind of an example of one of the graphics that would come out of kind of this digital twin. And so you can see that there's a couple different metrics that we're tracking, and the blue line is the historical data versus what the backtested data is. And then in here, I don't remember exactly which inputs I was changing. I think it was with growth, I was changing the storage. So I had a stepwise storage function. You can see where there's kind of like that inflection point on the green curve for collateral. That was where, I'm running an experiment saying what would happen if all of a sudden we had just a huge shift upwards, stepwise. What would it look like in terms of the effects on these different metrics? And so for this one, there isn't a lot of variability, but if you look closely enough, there is kind of that cloud. And this is kind of the output. There's also an ability to do A/B testing. So having different parameterized Monte Carlo runs and being able to compare two sets of Monte Carlo runs in the extrapolation phase. But most of the outputs look something like this. And it's just a large notebook that also gets written as an HTML report to allow for kind of easy sharing.
Yeah. And also keep in mind that these are always slices, because these systems are way more complex in terms of the number of interacting variables than can fit on any plot. So any plotting exercise is also a framing exercise, and says, okay, well, what was this experiment expecting to elucidate? And so then we might look at metrics that are specific to the experiment. So as Sean noted, this experiment came from a particular what would happen if, and then we're looking at an experiment where that change was made, and then we look at what the consequences are on a handful of relevant metrics. And there's there's basically an infinity of types of questions you could ask and experiments that you could run, but some of them are actually more useful from a governance perspective than others, or from a user perspective as well. So don't want to oversell it, but the point is we just grabbed a slice as a demo, as an example. I guess I want to also thank our team members. There's a bunch of people who we didn't actually call out. So Jamshid, who's an economist who's been working with us, he's amazing in terms of like cloud infrastructure and figuring out what performant digital twins could look like. We have Emmanuel, we've got Danilo, who's like really an expert in digital twins. He's originally a like climate systems modeler. So he had a lot of experience with this kind of dynamical systems modeling plus noisy data, plus sort of back testing and extrapolation and scenario analysis from the climate modeling industry. Let's see, Andrew Clark has been doing, he's also an economist, has been doing a lot of the sort of data science, some of the data cleaning and dealing with some of the stuff that's coming out of Sentinel. And there's some mismatches between the expected nature of the data. He's been doing things like VAR analysis, like time series analysis to refine the modeling of the stochastic processes. Who else? Just trying to make sure that we don't overlook the number of technical people who have worked together to help make digital twins a reality. The original design digital twin, one of the major contributors was Marcus Koch, who's now actually the head of product at Balancer, but worked with us for a long time. Please tell me I didn't miss anybody. Josh, who did the development of CAD originally and has continued to support our efforts to use it for these more large scale systems. I didn't miss anybody, did I, Sean?
I don't think so. I think you're good.
Cool. So then thank you guys for listening, and we can do Q&A. I hope you kind of see how we've come to where we're at, where we're doing what we consider like pretty heavy, like data science and data engineering work, but ultimately we want that to be more like civil engineering and less like we're not trying to push an agenda. We're trying to understand what it would mean to do economics work, data science and economics work with a pretty high fidelity expertise, the climate modeling actually probably being a good analogy, where like we're just trying to understand what's going to happen and to inform policymaking with some, at least the best we can provide in terms of understanding of the consequences of decisions.
Yeah, and thank you guys for jumping in and being so willing and enthusiastic to present as we've scheduled. We've had to reschedule this forum several times now, the entire summit, so I appreciate you being so responsive. I'm gonna hold back to see if others who are able to join have questions, since this is the first time they've learned about much of this work, I think. And if this is all completely new and you're still digesting it also, we do have shortened meeting notes that I took throughout this call, so you can take a look at those and use them to help frame some of your thinking. I think this is actually really timely for the work we're trying to do related to FIPS and the broader processes that surround it. And specifically with the Crypto Econ Lab, one of the outstanding questions we have is how do we make better audits of potential FIPS? Very specifically, but how do we actually use this sort of economic thinking model to inform the way solutions to problems are actually designed? So when we think about how we could actually implement and use this digital twin in a governance capacity, it would be really exciting if we could collaborate to understand the release roadmap a little bit, understand where this is eventually going to be hosted once it's public, so that we can create these community linkages that we've been talking about all week to it. And also then begin to find folks who'd be interested in helping to build out dashboards or other productive tools that can use this data. From my own perspective, it'd be really interesting to find sort of like resiliency tipping points that can be generated through this to understand the scope of a crypto economic audit when we have specific FIP topics. So some have very little crypto economic impact, some it's immense.
risk
making-
analysis. And yeah, I'm with you. There's so many things that, we can imagine doing. I will point out though, that in terms of the roadmap, one big challenge that we've encountered is that our team we have a fixed set of resources that we map to this that's pretty large, but also has this challenge where we're also kind of we're trying to build the infrastructure to make this as scalable and community driven as possible. But we also do a lot of ad hoc analysis of specific, like a FIP comes up and it gets thrown over the fence, like, hey, we want your opinion on this. And then what we're doing is responding with our intuition, with a little bit of ad hoc analysis based on expertise that we have from building the digital twins, right? Lots of modeling, lots of data, but we don't have a tool yet in production where we would actually go ask a specific question and get an answer and use it. We're actually doing this with, we call it ad hoc, right? And so understanding that as a resource pool, we're sort of juggling between, infrastructure investment in building out and deploying and testing and documenting the digital twin versus doing these sort of ad hoc opinions, not even full audits. I wouldn't say that it's fair to call it that, but just like rendering an opinion internally with the crypto economics team, we find it actually pretty difficult to actually plan our roadmap, because while our long-term vision is very much everything we just presented to you, it is competing with the urgent need to answer questions about FIPS from a crypto economic perspective on a day-to-day, week-to-week, month-to-month basis. And so part of our maybe desire for collaborating with the governance, stream in the FileCoin Foundation is to sort of even further factor out the function of building governance data infrastructure that is governance infrastructure versus using it. And so while we're doing both, it kind of makes sense. In the early days, we actually would like to see those two roles treated as different but related. And it's okay if an organization does some of both, maybe, but also it's not a bad idea to have multiple organizations fulfilling the auditing type functionality and potentially rendering differing opinions, asking and answering questions differently. And it also makes sense to have second and third sets of eyes, or maybe more of an open working group model on the data infrastructure. But practically speaking, I see those things going in waves. Like the sharing of the role of using the tools can come in effect before the sharing the role of building and hosting the tools, just because of the depth of expertise required.
Perfect. Yeah, ZX and I were talking about this just the other day. He's actually on PTO right now, I think. But one of the things we're trying to figure out is how we can actually organize these audit needs. And I think the way you outlined it is exactly what we're thinking. So I think the action item there is that we can follow up directly offline. I want Danny to be able to ask his question, but I think it's important that you, myself, Shannon, if you're curious, and also the rest of the Crypto Econ Lab, both of them, connect to figure out how we can organize resources better, especially now we know in January, we're gonna have several huge FIPs coming up.
Yeah, so hi, I'm a fellow at the foundation. So one of the questions that I think was prompted by you mentioning in passing your work with Gitcoin and dealing with sort of fraud, but also is partly kind of what you just touched on now, which is sort of the interpretability of the model, right? Like you have to kind of sit there like the Wizard of Oz and kind of operate it for other people and like say, yes, it says this. There are clearly some advantages both for you and for us as the foundation to make make the twin more comprehensible and legible to a wider community of people. But there's also sort of a tension here, which this is specifically what I want to probe, right? Is that you can't, or maybe you can, but there are certain aspects of the model that you can't make public, right? Because then it really does become recursive, right? People begin to treat it like an oracle, or people are like sitting there going, what if I do this? Maybe I can game the system this way. How are you thinking about that? How are you thinking about how to like turn this stuff as an independent thing that other people can use? And what does it mean for you to like make this more visible beyond kind of like your individual customers like PL or us?
The short answer is very carefully. The long answer is really, I mean, we're quite deeply aware of the roles that models play in political processes. Like I didn't come to, working on digital twins for large scale economic systems lightly. My background formally is I have a PhD in systems and control theory from the University of Pennsylvania. My PhD advisor is the director of socio-technical systems at MIT now. Like I didn't come to the space with a naivety about the roles of models in maintaining infrastructure, the politicality of infrastructure. And it's been kind of a nightmare in Web3 in a lot of ways because there's a tendency towards the belief that there's some perfect model somewhere, or that if you just find the answer, you're done. And these assumptions are actually problematic from a governance and maintenance of data infrastructure as infrastructure for political processes. So short answer is, well, it's not solvable, strictly speaking. It's manageable if you understand that that's what the game of games that you're playing. And a lot of our Web3 experiences have been heavy on education and light on kind of new innovations, because we've actually just had to try to get people to level set. And like with the Gitcoin example, I mean, we were building an algorithm, we prototyped and built an algorithm that does fraud detection flagging. I mean, that's about as canonical of a justice problem as you can get, because you can never get away from type 1 and type 2 errors, and then how you choose to prioritize the objective functions in the model and how you validate its performance, et cetera, all are inherently policy-making decisions. Now, from a data science perspective, there's poorly and well executed. Like I could do something that's worse, but I can't necessarily do something that's given I've excluded the things that were not in good practice, amongst the things that are in good practice, there's still a lot of subjectivities remaining, and there are real ramifications on end users of those subjectivities. And trying to put like multi-layer institutional processes in place around these things is a bit of a haul in a community that doesn't yet understand that the thing being delivered is subjective, or at least partially subjective. And so in that system, the best examples are that, well, we built the tool internally and we operated it. Then we started building a sub DAO home for it in the Gitcoin DAO. And we're currently working on transferring ownership and operatorship of it to a group of stakeholders within the community. But that itself is actually involves both the technical expertise sort of working together and getting on the same page in terms of feature engineering, like data collection and cleaning, and feature engineering and model selection and validation procedures. And we also do human validation oversight processes that involve running surveys. Is this a Sybil? Is that a Sybil? And like try to build data sets that we use to train. So this whole operational process had to get deployed by us operating it, then inviting other people in the community to participate in a gated way, to your point about gaming that, because once you can see in it, you have an extra power to maybe evade or prioritize. Like there's all sorts of issues that come with that. So you need to have trusted collaborators and varying degrees of visibility into how the thing works. And honestly, in that case, I would say we're further along than we are in any sort of FileCoin digital twin, because we're dealing with something as not complex as a machine learning pipeline that flags someone as civil or not. It's actually significantly less complex and less political, because people more or less agree on what it should do. We can get feedback through human flagging processes. It's a supervised learning process with a participatory supervision process and a set of stewards capable of saying like, hey, we want you to lean the meta parameters towards type 1 versus type 2 or vice versa. And that's something that an end user governor could actually have an opinion on, and that we could recognize in the code and demonstrate. But then in something like the FileCoin digital twin, you have a much more abstract set of macroeconomic dynamics for which it becomes increasingly difficult to understand what that governance of the models actually should look like.
So I guess, I mean, to put a finer point on it, like one of the sort of things that's built into Protocol Labs sort of set of values, and kind of the ones that we kind of try and execute on, is openness and transparency, right? If we're building a decentralized system here where people can see, that they are a stakeholder and they understand how this process, and there is a democratic consultation about say PIPs, right? There's this challenge if like, how do you deliver or include the data that comes from the model, right? Because we could go in and go, well, the model says this, right? And then people will go, what? Like, who show me, right? And there's one thing, which is you go, actually, we can't show you because it's just hugely complicated. And we had to just talk to, Sean and Z and people to like explain
But we
it.
don't want that, right?
Right. But then there's this other thing, right, where we go, okay, we have some transparency to showing you what the digital twin does, but a couple of things, right? One is that slight feeling of, okay, are we revealing something here that means that people will be able to exploit? And I don't think that's a problem, right? Because I think from a security point of view, like the fact that it's transparent or emergent from playing around the digital twin means it's something you should fix, right? And it's better to have that part of it open. But the other part of it is in the stuff that we're talking about here, we're kind of modeling the stakeholders themselves, right? Like there's bits of this where we will be going, and if this bit of the crypto economics works like this way, then these people will be incentivized to leave the system, or they will lose out to a certain degree. And that's the people who are going to be voting on this. So there's this double-barreled thing of seeing themselves in the model and also going, but we wouldn't do that, so this model is wrong. Does that make sense?
It makes sense, but I also want to make a really important point about the whole CAG map thing prior to the discussion of the digital twin specifically. From a participatory informed decision-making standpoint, we are taking an epistemologic position that a large number of the assumptions in the model should be very clearly articulated as assumptions. So, and it's not, the model doesn't say anything. The model only says things conditioned on things. It is not a oracle, it's a pipe. So if I say, suppose people behaved like this, then now if I want to say, people aren't going to behave like that, then that's an A/B test candidate right out the gate. People feel like that's not how people are going to behave. Great. Let's suppose they behave the way that you think. Now we don't have an oracle. We have a thing that says, look, some people believe people will behave like this. And if people do, then, and vice this other thing. And so when we de-unique the model as early as possible. Every model has assumptions. Every model is wrong. The conclusions are going to depend on the assumptions. The conclusions are also going to depend on the goals, which is almost as important as depending on the assumption. Because I might say, I want this to happen, and maybe we all agree in these assumptions, and here's the model, and I want outcome A. And I say, we should do X because X is almost certainly going to give outcome A. And here's my proposal and all of my justification. Somebody else goes, whoa, I don't want A. A is terrible. A is bad for me. I don't like A. So then I'm like, I want the system to do B. And I'm like, well, then we definitely shouldn't do X because X causes A, the opposite of B, and I don't like that. And so when we talked about CAG map, that was there to point out that we are as early as possible trying to disabuse people of the idea that the model set is reality. The model is a thought experiment, a data-empowered thought experiment, an economic theory-empowered thought experiment, but it should not be elevated beyond tool for collective decision-making by humans.
Yeah. So the word
really quickly. So I'm happy to make you the host, Danny, but Shannon and I do have to leave. We have another back-to-back session to host.
I'm done. So
I don't want to interrupt your conversation.
I think de-unique is the bit that I took away from that, which is a great phrase to like removing its kind of, oracle-like status. So thank you for answering that. Thank you, Caitlin, for.
I hate to be the bearer of bad news to interrupt. Again, I'm happy to try and make you the host to see if you can stay on the Zoom line together. We'll have to drop. I'm not sure if it will allow us to maintain the meeting space. But again,
we've taken up Sean and Doug's time enough, so I'm done.
All right.
No, very, very helpful.
Yeah, I want to thank you guys again. Sorry for stopping us more abruptly, but I'll share the meeting notes again, and Zargham and Burrata specifically, and Sean too. I'll follow up directly. We have a couple of action items so that we can continue to collaborate on this, but I think we're all really excited and aligned on where it can be really useful for governance. And thanks for your question, Danny. It's good.
Thank you.
For listening.
Right.
Thank you, guys.
Bye, guys.
Bye.
Cool. Thanks.
Yeah. Enjoy San Francisco.